Hi everyone, my name is Eric Bellm. I'm the Alert Production Science Lead for Rubin Observatory Data Management. Today I'd like to tell you about the status of the selection process for community alert brokers, progress we've made on producing sample alerts from precursor surveys using the Rubin Observatory pipelines, and some ideas we have about potential changes to the architecture of alert distribution, which we'd like your feedback on. If you're new to this area, I would suggest taking a look at this document, Plans and Policies for LSST Alert Distribution, LDM 612. There's a link here in the slides, or you can go to the URL shortener ls.st/LDM 612. It gives a high-level overview of the different moving parts that make up Rubin alert production, talks a little bit about, summarizes the relevant data rights issues, and it goes into detail in how community alert brokers are being selected. There are a handful of other documents that may also be useful. DMTN 102 provides key numbers for alerts in terms of the number of alerts per visit, the number of visits per night, how big are the alerts, and so on. The Data Products Definition document, or DPTD, is our best summary to date of what we expect to be in the alert packets. And DMTN 93 talks about the design of the LSST alert distribution system in terms of alert serialization, alert transport, and so on. Finally, there is a useful page on lsst.org for scientists, under For Scientists, about alert brokers. So first, I promised an update on the status of the broker selection process. It is ongoing. So we issued a call for full proposals for community alert brokers back in December of last year. We invited all of the teams that had submitted letters of intent to submit full proposals. And those full proposals were originally due in June. However, due to COVID-19, as well as delays by DM in getting our sample alerts out to the broker teams, we chose to delay that due date for full proposals until at least December 15th of this year. As of this moment, we are expecting to hold to that date, and so I would encourage the broker teams to continue to work to that date. The selection is going to be conducted by the Rubin Observatory Science Advisory Committee, or SAC, and we'd expect that this provisional selection of the alert brokers will happen in second quarter of 2021. Onto sample alerts. So as described, as mentioned, we have promised sample alerts to the broker teams to allow them to prepare for the full proposal process. We also realized and recognized that they would also be useful to the community and in turn back to us in allowing everyone to understand what's in the alerts, how are they formatted, and how are they transmitted. So if you're a science user, we'd encourage you to take a look at these sample alerts and think about how you would use them to find events of interest to you and to see if the fields we're providing, the quantities we're computing are the correct ones for your science, while we still have some runway to make changes. It also helps, providing samples also helps provide some clarity around the alert formats. How do we concretely get values into and out of an alert packet? And for the alert broker teams, we want to give an opportunity to understand the protocols by which we'll transmit and stream alerts to the community brokers. So as mentioned, there was some delay relative to our original timeline in providing that initial release of sample alerts, but in July we did release it along with some documentation and some software. So the documentation, again linked here in the slides, is in a GitHub repository called Sample Alert Info, which we envision as a sort of a living README that points to updated data and software. The sample alerts themselves are from the DECAM HIT survey processed through the Rubin Science pipelines. We've serialized about 1 million alerts on disk in Avro format. These are all G-band from HITs. And during the LOI stage and the broker workshop that happened last year, there was a great deal of interest in understanding the format and contents of the prompt products database, or PPDB. So we're also providing basically the equivalent of the PPDB as a SQLite database, which can be downloaded from the same source. So all of the alert contents are from that PPDB, which is just a relational sort of formatting of that data, obviously with the exception of the cutouts, which are included in the alert packet. In terms of software, the release includes a package called Alert Packet, which is intended for end users and so is pip installable with relatively few dependencies. It has the schemas in it and some simple utility code to make it a little easier to read the alerts. There's also a stream simulator, which is a Docker-based tool which wraps up Kafka and some other things for broker teams so that they can use the sample alerts and simulate streams of various sizes, perform basic loading and ingestion tests. The sample alerts are intended to be a preview, again, of what you can expect when Rubin runs on real data. And they're run on precursor data from a real telescope, processed by the pipelines as they exist today. So there's certainly plenty of artifacts. We estimate around a 4-to-1 bogus to real ratio. And of course, because it's not the LSST survey, the cadence, volume, depth, filter set are not representative of what we'll see from LSST ultimately. However, it's real data, there are real objects in there, there's no sort of simulation selection effects or biases that are present. Because the pipelines are still in active development, a number of the DPDD fields that are called for are currently missing. These are detailed very extensively in the sample alert info README. In particular, I wanted to call out, we don't perform trailed source fitting yet or associate to known solar system objects. We don't have the extendedness or spuriousness scores or time series features computed. Obviously, we will update the sample as we continue to add new features to the pipelines, and so sort of asymptote towards the final alert formats as we move into commissioning. And we'd really welcome your feedback and questions and suggest that those should come through the community data Q&A topic, again linked in the slides. One thing to watch out for with these alerts is that they have very large cutouts in some places. This is the result of a requirement and a number of choices. The DPDD suggests that the cutout should be variable sized and cover sort of the entire detection footprint. So you can look at large scale trailed near asteroids. And sort of when we were first setting this up, I told the team, let's make square cutouts and center them on the dia source because that's what is useful. That's what is sort of standard. But as a result of some bugs and detection artifacts like long bleed trails, what this led to in practice was some cutouts where you have sort of the entire CCD worth of data included in the cutout plus additional padding blank space because the CCDs in dark energy camera are not square. So we're doing a number of efforts to mitigate those artifacts, sort of avoid generating truly enormous cutouts. But in the latest sample, we just went ahead and sort of manually stripped out the sort of greater than 4 megabyte scale cutouts that are not really physical and make it hard for the alert simulator to work as expected. This is an example of a very nice figure that one of the broker teams, Julian Peloton, contributed on the community page when asking questions about this. This is a histogram of the sort of one-dimensional size of the cutouts included in one of the samples. And so you see that the modal cutout has sort of 30 by 30 pixel size, the minimum required. And then there's a long tail to sort of CCD scale sizes. And again, remember, this has already been truncated for even to remove the very largest cutouts. Other software, again, we're providing a stream simulator that's intended mainly for broker teams thinking about receiving the Kafka alert stream. Um, and so this is, again, using Apache Kafka as ETF does as well to stream alerts to community brokers. So the stream simulator is a sort of a standalone way for brokers to, on their local hardware, take those input alerts and try to test scale and ingestion and so on. And so there's a tech node DMTN 149 that describes our goals with that stream simulator. We're not intending in the immediate term to do sort of data center to broker interface tests. Those will be deferred until probably after the broker selection is complete. Finally, I wanted to bring up some ideas that have been percolating for a while. Certainly, we discussed aspects of them at the community broker workshop last year in Seattle, but have sort of taken off a little bit thanks to our one of our new hires, Spencer Nelson, who's at University of Washington and is focusing on the alert stream. So, you know, it's very clear that as designed, the Rubin alert packets are very large, and that causes some challenges. The idea of these alerts is that they are sort of comprehensive. They have basically all of the data you could want: the triggering DIA source record, the associated DIA object or SS object record, 12 months of history, and then of course those variable size fits cutouts that we just discussed. And the idea here is, again, to allow them to be fully world public, easily redistributed, you know, sort of self-contained, and allow users to do very rich queries and analysis to determine very rapidly if this is an event that is of interest. And the challenge, of course, is that we've seen these packets, you know, are certainly tens or hundreds of kilobytes up into the megabyte range with some of the larger cutouts. Which places a huge strain on the bandwidth if we have to get these out in a timely manner, and also challenges, frankly, the alert distribution infrastructure. And what this leads to is a model, again, where you have only a handful of maybe 5 sort of large monolithic brokers who are responsible for receiving the stream and serving it and redistributing it to the whole worldwide community. And so here's that sort of architecture as a flowchart. The box on the left is showing alert production, where the images come in from the observatory and are subtracted, and then are packaged into alerts and are queued up in a Kafka queue that goes out to event brokers, who then serve public users as well as users with data rights. Data rights holders can query back into the LSST Science platform and query, you know, the prompt products database, data release databases, and so on, and use the alert filtering service. Some of those with delays beyond, you know, 24-hour timescales rather than the 60-second alert latency. Our goals, as we thought about, again, alternatives, is to sort of improve generically performance and access. You know, we want to maintain all of that rich content that's in the alert packet that allows the, you know, really comprehensive filtering and analysis for the broader public. And but at the same time, we'd like to enable more folks to get their hands on the stream as quickly as possible. You know, and as a nice sort of idea or goal, thinking about, you know, wouldn't it be nice if you could just, you know, connect to the alert stream from your laptop and have that be functional and practical. And finally, we want to obviously maintain the important role that community brokers have in facilitating public alert access, providing all the rich value-added services that that they're planning to provide. So we approach the problem with those sort of goals in mind, and it's, you know, the sort of key aspect here was that separating alert notification from the entire packet content has some appealing features. The idea here would be to really strip down in a very extreme way to a sort of a minimal packet that would be in sort of what we're calling something like a notification stream. You know, you could think of still using Kafka for this. It really contains just a bare minimum of science data. So you could, as a science user, think about filtering that down by a large factor to alerts of interest. And so it's not intended to be a comprehensive packet. We still have the full packet, which I'll describe in a minute. But this notification just has a really simple information to say, yes, this might be something I'm interested in, or no, it's definitely not. And so that's things like, obviously, the position on the sky, when it was observed, the filter, how bright is it? You know, was it in a special program? Was it associated with a solar system object, or is it trailed? You know, is it a bogus object, bad subtraction? How far to the nearest star or galaxy? Obviously, having some, you know, brief handful of features that capture time series behavior. How variable is it in time? Has it been detected before? When was the last detection? And then finally, an identifier that lets someone who says, yes, this is of interest, go back and get the rest of the data, that full 12-month history, the cutouts, and so on. So if you sort of write down the number of fields here, that comes to around 200 bytes of data for one packet, rather than, you know, 100 kilobytes or a megabyte. And that would, in principle, allow, with the same sort of bandwidth, you know, of order thousands of users to think about connecting to the full alert stream, which is a very exciting improvement in the capability of what we'd be offering. So then we want to give users a way to then retrieve that rest of that data, again, without going back and querying all the databases and causing a big load on the databases. So we would still create the complete alert packets and sort of with all the contents the DPDD described. But imagine storing them in something like an object store with sort of an HTTP interface, as an example. Something really standard and sort of web scale, straightforward to administer. The nice aspect here is that you can set rate limits pretty easily. And so for an individual scientist, that would be consistent with, you know, pulling out a few alerts. Whereas if you were a selected community broker, you'd have very high rate limits that would be consistent with pulling the whole alert stream in real time. There's, I think, potential here for actually better performance. Users are able to parallelize downloads of these full packets, or to schedule them, or to defer them to times that are more convenient, as opposed to having that full Kafka stream of giant packets where you have to run through and touch basically all of the bytes in order to get to the next one. And you could also imagine various kinds of optimizations where, you know, maybe it's easy to enable just retrieving the cutouts, or not retrieving the cutouts and just getting the history, and so on. So I think there's lots of options and details here to work out, but the idea is that you know, we could enable it users to pull more information, but the information that they need in an efficient manner. And so the point is that, you know, science users would receive the notification of every LSST alert, but only need to come back and pick up the larger packets for a small subset of those data for more detailed analysis. Probably because these services are living on Rubin facilities within the data center, within the data facility, probably that direct access is going to be restricted to data rights holders, and as well as the selected community brokers. And so community brokers are still serving as the hub for public access to alerts. Again, I'm speculating here. This is a concept, but this seems like a fairly natural extension of existing policies. So again, here's that flowchart showing this alternative idea. Relatively little has changed here, except that now we have the data rights community is able to connect directly to the now thin sort of Kafka stream of alerts, but a subset of the contents, and then go pick up full-size alerts from an object store. And similarly, event brokers are receiving that notification stream and then retrieving all of the alerts out of this object store as they come in. So this is an idea. There are lots of sort of knobs that can be turned here. Again, our goal is to provide more value generically to the broad scientific community. We're not reducing or changing the alert content that is being produced or made public, and it's being made available at the same speed as before. There's no change there. And we're, again, committed to making sure that this is going to work well for community brokers. In fact, we hope it will make it better in terms of providing more flexible interfaces and potentially being able to connect more brokers than we would in a very full stream sense. This is in the early stages of discussion and evaluation. We're not going to be able to make much progress on this problem, at least until early 2021. And so we're happy to take the remainder of this year to listen to and respond to feedback and suggestions. So just to conclude, the selection process for community alert brokers is ongoing. We're looking forward to reading those full proposals when they come in at the end of this year. You're welcome to go and poke at our sample alert packet and tools, and we will continue to add data sets and improve their completeness and feature completeness, as well as general performance. And we'd also welcome your ideas and thoughts about this idea of a sort of a lightweight notification stream that could be shared more broadly rather than sending just the really heavy packets. So thank you very much, and happy to receive comments, questions, and feedback. Thank you.